Welcome back, everybody. We have a lesson today involving scale models and scaling up using scale factors to determine how large actual objects are compared to their models and how far actual distances are compared to a map. Let's have a look at this first one. At a height of about 212 meters, one shell square is the tallest building in New Orleans. Marlie is creating a scale model of this building using a scale factor of 1 to 250 to the nearest tenth of a meter. What will the height of the scale model be? So here's what we're going to do. We're going to make that ratio 1 to 250. Think of the top number as the model and the bottom number is the actual real life. We're going to set that equal to x over 212. Notice my bottom numbers are the actual, the real life measurements, and the top numbers are the model measurements. Okay, so at this point we're going to crisscross multiply. When you get your ratio set up, 1 times 212 is 212. 250 times x is 250x. I'm going to solve for x by dividing by 250 on both sides. 212 divided by 250, calculator says 0.848. That's how many meters on the scale model is of the building, but we need to round it to the nearest tenth of a meter like it says in the problem. So 0.8 is the height of the scale model, 0.8 meters. Let's look at another one. It says the actual distance between two villages is 120 kilometers. On a map of the area, 0.5 centimeters represents 2 kilometers. What's the distance between the villages on the map? Okay, so we have that ratio of 0.5 compared to 2. Just so we know, the top is our map and the bottom is the actual. As long as you keep that in mind when you're making the ratios, you should be good to go. It says the actual distances between the two villages, 120. We want to know what is that on the map. That's what this x represents. Alright, a little crisscross multiply. 0.5 times 120 is 60. 2 times x is 2x. And again, we got that from crisscross multiply. Divide by 2, divide by 2. X is equal to 30. On the map, it's only 30 centimeters between the two villages. This one, a town is designing a rectangular park that will be 600 feet by 1,000 feet. The rectangular area of the park for swing sets will be 25 feet by 100 feet. On a scale drawing of the park, the swing set area is only 0.5 inches by 2 inches. What are the dimensions of the park on the scale drawing? Okay, so we have the actual, alright, and we have a couple of numbers here that will kind of drive what we do. So just the swing set area on the scale drawing, it's only 0.5. Alright, so let's keep that in mind. 0.5, that's the drawing. The top numbers of our ratios are going to be the drawings. The actual will be the bottom. So 0.5 inches on the drawing. The swing set is 25 feet in actuality. Alright, now there's a couple of steps to work here. We need to find the dimensions of the park. So we have this ratio of 0.5 to 225. We need to find what the park is on the drawing. Okay, so this 600 here matches the smaller dimension of the park. So that 600 is going to go right here. And this x right here will tell us the dimension of the rectangular park, the whole park, on the drawing. Alright, we're going to do crisscross multiply once again here. 0.5 times 600 is 300. 25 times x is 25x. We're going to divide both sides by 25. 300 divided by 25 is 12. So one dimension is 12 inches. Still got to find the other dimension. We're still going to use this ratio right here. That's going to drive our other dimension. 0.5 divided by 25. Alright, equals x over. This time we're going to use 1,000 feet instead of the 600 because we need the other dimension, right? Alright, crisscross multiply once again. 0.5 times 1,000 is 500. 25 times x is 25x. We'll divide both sides by 25. 500 divided by 25 is 20. There's our missing dimension. So, the dimensions of the park on the scale drawing would be 12 inches by 20 inches. So I did 2 sets of work there. Alright, moving on. Let's look at another one here. It says Mason is building a scale model of a truck using the scale factor 5 to 64. Maybe we should write that down right away as a fraction. 5 to 64. The actual measurements of the truck are given in this table. What's the length of the model? Now they give length, width, and height, but we only need the length. Alright, again, we have top number is the model, and the bottom number is the actual. 5 over 64 equals x over 230. Crisscross multiply. 64 times x is 64x. 5 times 230. Calculator says 1,150. We will divide both sides by 64. Alright, x comes out to be 17.96875. If we're just going to round that to the nearest tenth, say we did the nearest tenth, it would round to 18 inches. And that is the length of the model. In real life, 230 inches. The model is just 18 inches. Let's look at one more. On a scale drawing of a museum, 2 water fountains are 10 inches apart. The actual distance between them is 400 feet. On the same drawing, the distance between the 2 exhibits is 3.125 inches. What's the actual distance between these 2 exhibits? So we're going to use the 2 fountains. That kind of gives our ratio, and the ratio is 10 to 400. Alright, so the top number is kind of the model or the drawing, and the bottom is the actual. Alright, and then on the drawing, the 2 exhibits, we're going to do the drawing, goes in the top, 3.125. We're going to go x to figure out the actual distance between those 2 exhibits. Crisscross multiply. 10 times x, 10x. 400 times 3.125, 1,250, according to the calculator. Divide by 10, divide by 10. X is 125. The actual distance between the 2 exhibits, 125 feet. Thank you for watching. Hope this made sense as we worked on scale factor problems. Thank you. Hope to see you again.